If you flip to the back of your cheat sheet, you'll see 3 distinct sections that cover the 3 different types of reactions that I need you to become a pro on over the next 2 weeks. Each of the types of reactions has a certain skill associated with it that I need you to get good at. We're not doing that today, though. All I need you to be able to do today is if I give you a reaction like the one you did in your F5, you can tell me which of the 3 types it is just by the way it looks. For example, I know that the one that we just translated is a redox reaction. And you'll be able to tell that too by the end of today using a very easy list of characteristics you're identifying. But before I start introducing the 3 different types, there's some basic vocab that I'd like us to be on the same page. So look here and just kind of answer out loud. Is that a free element? No, it's not, because there's multiple capital letters. That is not a free element. Is that a free element? Yes, because he's all by himself. Or, I guess, check. I don't really know what my system is. Oh. He is a free element. Is that a free element? Yes, it is. The whole point of this exercise is for you to understand that that 2 there doesn't make him not a free element. That 2's there because he is a free element. Bromine's diatomic, so if he tries to exist by himself, then he needs that 2. The only one of these examples that's not a free element is the one that contains multiple capital letters, if you want to think about it at an elementary standard. But these 2 guys are all by themselves. It's just single elements. That makes them free elements, which is a big deal in the exercise we're about to do. Let's look at an unrelated topic. We're going to be introduced to acids and bases today. As is written on your cheat sheet, acids and bases can be determined, distinguished by very simple characteristics. If you're looking at a formula, you're going to see that acids always start with hydrogen. It'll be hydrogen followed by something. And you know the compound you're looking at is acidic. For example, that's hydrochloric acid. You don't need to be able to name that yet. All right, I'll teach you how to name acids at a later time. But the fact that it's a compound that starts with H makes it an acid. That's sulfurous acid. But right away, even though you don't know to call it sulfurous, you know it's an acid because it starts with H. Now that's in the formula form that you'll use that trick for acids. In the English wordy form, they're even easier to identify because they'll contain the word acid. This is hydrochloric acid. This is sulfurous acid. So if I give you a wordy form like in your F5, and you're wondering whether or not something's an acid, it'll really jump at you. But otherwise, any compound for our purposes that start with H, I want you to identify as an acid. Bases are just as easy to identify, but they're different. Bases are compounds that end in OH. Again, anything can go into that line, but if it's a compound that ends in OH's hydroxide, you can verify that on your polyatomic list, it will be a base. So some examples could be lithium hydroxide is a base. Beryllium hydroxide is a base. Aluminum hydroxide is a base if the compound ends in OH. In the wordy form, like the F5, you would look for, well, the name of him as the second part, and again, it's hydroxide. So this will take a little bit of getting used to, but by no means is it difficult. But it'll be important for what we're about to do. Any questions about anything I've said? Now, if you look on the back of your cheat sheet, you'll see that everything I just said is written there for the different sections. You can find those definitions. Also on the far whiteboard, which is what we're about to use, it mirrors some stuff that's on your cheat sheet so that I can reference it, but you can see some of this stuff is applicable over there. So let's take a look at what I want us to be able to do. Write down this first example in your notes with me. We'll be identifying 6 different reactions today. The order in which the back of your cheat sheet lists the 3 reactions is the same order I want you to try to identify reactions in. In other words, it's like a checklist. You're not familiar with them yet. You'll see they're called redox, neutralization, and precipitation. But if you look at your roadmap, they each have their own lecture day. So we're going to get intimate with all 3 of them. But today, you're just going to learn how to identify them. But what I'm saying is you're going to go down a checklist, section for section, figuring out which is which. And here's how it works. Follow along on your cheat sheet while I point to the whiteboard over there. Sorry, I can't move from my computer. They can't hear me. But if you look at a redox, in order for a reaction to be redox, it says a free element must be reacting. Look at my reaction here. Do you see a free element anywhere? No. If there's no free elements, then it's not redox. And now we can go to the next section on your cheat sheet to see if it is neutralization. If you read my whiteboard, it says to be neutralization, you must have an acid reacting with a base. Now, you just learned what an acid and a base is. In other words, one of these guys needs to start with H, and the other guy has to end in OH. Is that happening here? No. It's not neutralization. Now, we care what precipitation says, but you can kind of use it as a trash can option. If you're sure it's not redox, and you're sure it's not neutralization, you can just assume that it's precipitation. But just to prove it to you, the definition of precipitation says 2 compounds reacting together to form 2 new compounds. What type of reaction is this? It's precipitation, and we're done. Let's do another one. There are 3 types of reactions. I want you to always start with redox because it's the safest order to try to classify them as. So right away, in order to be a redox, there must be a free element somewhere over here. Do you see a free element? There he is, sodium all by himself. Therefore, what type of reaction is this? It's a redox reaction, and we're done. Now, after we have our later units, once you identify it as redox, there'll be a redox step to do. We're just not doing that today. We had 2 boys try. Would any females like to try to say this reaction? You don't have to raise your hand, just go for it. Go for it. Nope. So, in the previous ones, it was covalent compounds, which is why the prefixes were, there's 5s and 7s and stuff. This is not covalent. There's polyatomics everywhere. So it's actually going to be named using ionic rules. Hydrogen nitride reacts with aluminum hydroxide to produce aluminum nitrite and water, or dihydrogen monoxide would actually work there for that molecule. Is it redox? Why not? There's no free element, so it can't be choice number 1. Let's go to choice number 2. Is it neutralization? It is. In order to be neutralization, one of them must start with H, and the other one must end in OH. Those are interchangeable. Please understand that. It can be an OH reacting with an H. That would be the same thing. Also understand that you can't just have half of the requirements for neutralization. He's an acid because he starts with H. But if this guy didn't end in OH, it still couldn't be neutralization. It's got to have both. An acid starts with H, and a base ends in OH. Just like here. This is neutralization. Those of you at home, pause the video, see if you can identify all 3 of those. Let's see how you did. Go in my order, and you can't go wrong. So I always check redox first. Can my first reaction be redox? It can't. There's no free element, so I go to my next option. Can it be neutralization? It can. Look, he's called hydrofluoric acid. He's called ammonium hydroxide. If an acid reacts with the hydroxide, it's neutralization. Go back to the top of the list for our next example. Can he be redox? No, there's no free elements. Everything's a compound. Is he neutralization? No, we have none of the requirements anywhere. Neither of them start with H, neither of them end in OH, so we could right away make the assumption that we're dealing with precipitation. Let's reset our list. Is this redox? Right away we know that it's redox because there's a free element. So we don't even have to continue. How did you do? Still easier than stoichiometry? Yay! Have a good day!